All right, good morning, everybody. So today we're going to continue our discussion in the prerequisite chapter 4, and this section still is going to be dealing with factoring. And specifically, we're going to talk about factoring trinomials with binomial factors. So if you remember back to some of the factoring that you did last year, this is probably some of the more basic stuff that you did. So let's get started. So the first question I want to take a look at is we have x squared minus 7x plus 12, and we need to factor that. And so you can see it has three terms. The other key to this is that the leading coefficient on the x squared is 1. So many of you may have been taught how to use the ABC method, and you always use that method no matter what. But what I would suggest is that the ABC method is a little bit of an overkill for this particular type of problem. And the reason why the ABC method is overkill is that the lead coefficient in this trinomial is 1. So if this lead number right here is 1, you can simply look at the rest of it and come up with the answers that you need to factor it. And so what you do is you're going to look at this number right here, this positive 12, and you need to think of all the factors of 12. And then you need to figure out which pair of factors of positive 12 would add to give me negative 7. So again, we need two numbers that multiply to be positive 12 and add to be negative 7. So the first thing that we need to realize is that if two numbers are going to multiply and be positive, but add and be negative, both of those numbers need to be negative. So in this case, we're going to be dealing with a negative times a negative will give us a positive, but a negative plus a negative will be negative. The next thing we need to do is go through the factors of 12. So you have 1 and 12. If you added those two numbers, negative 1 and negative 12, you would get negative 13. So that's not going to work. You could go with negative 2 and negative 6. Those two numbers would add to give us negative 8, though. So that's not going to work. You could go with negative 3 and negative 4, and those two are going to be the two that we're looking for here. So if we get in our head the two numbers that we need, which are negative 3 and negative 4, you can simply split them into the two factors. And you can see it becomes x minus 3 and x minus 4. And it's because negative 3 times negative 4 gives me positive 12, but negative 3 minus 4 gives me negative 7. So looking at these and applying the same logic as we used in the last problem, the lead coefficient is 1, and because the lead coefficient is 1, we do not need to use the ABC method. We could just try to come up with two factors that multiply to give me negative 6 and add to give me positive 1. And those two factors are going to be positive 3 and negative 2. So if I take positive 3 and I multiply it by negative 2, I get negative 6. But if I take 3 and I subtract 2 away, I get 1. So again, positive 3, negative 2. Those are the two factors we're looking for. So you can simply write x plus 3, x minus 2. So you can see it just splits into this x and then the numbers that we come up with. And these simple trinomials will always factor that way if they're able to be factored. There are some that are not able to be factored. But again, the key thing to this is keeping this lead coefficient to be 1. If this lead coefficient is a different number other than 1, you can't do it like this. You need to use the ABC method, which I'll go over in a little bit here. All right, so we got another one of these. Lead coefficient is 1. This is a quadratic trinomial. Quadratic means it is to the second power, and trinomial means there are 3 terms. Therefore, we're going to try to factor this, the basic factoring. Two numbers that multiply to give me 24 and add up to give me 14. And so you can go through the factors just like I did. 1 and 24, that's going to give me 25, so that doesn't work. You could do 2 and 12. 2 times 12 is 24, and 2 plus 12 is 14. So there are our two numbers, positive 2 and positive 12. So this will split into x plus 2 and then x plus 12. Much quicker than the ABC method. Now, the next technique that I'm going to show you is how to factor by grouping. Now, grouping is a specific technique we use in factoring for a very specific circumstance. And that circumstance is if we have 4 terms in our expression that we are trying to factor. So in this case, this has an x cubed, and then a minus 2x squared, and then a minus 3x, and then a plus 6. So you can see we have 4 terms. And so because we have 4 terms, we are going to group the first 2 terms together, and then we are going to group the second 2 terms together. One thing that I want you to note is this negative right here that would be on the 3x goes inside the parentheses with the 3x, and then there's a positive in between. You cannot leave this negative outside when you group, because if you were to group it right here between the 3 and the negative, then it would mean this negative would then distribute to both things and it would change our problem. So keep in mind, if there is a negative on the third term, the negative needs to go inside the parentheses and a positive, a plus, needs to be put there. So you can see we grouped the first 2 terms and then we grouped the last 2 terms. The next thing that we proceed to do is take out the GCF. So in this case, we took an x squared out, and you can see we're left with x minus 2. In this case, we're going to take a negative 3 out, and in this case, we're also left with x minus 2. And this is a very key part of this grouping factoring technique, is you have to be left with the same thing after you take the GCF out. So you can see here, after I took x squared out, I was left with x minus 2. After I took negative 3 out, I was left with x minus 2. If these 2 things don't match, one of 2 things, it means one of 2 things. Either you didn't do it right, or, which is a possibility, or the problem is not factorable using this technique, which is also a possibility. And you will run into that this year. So just know that once you take the GCF out of each part, what you're left with needs to be the same in order to do the next step. And that next step is to regroup the 2 GCFs that you took out and then write one of the x minus 2's. So you can see I wrote x minus 2, and then I regrouped the x squared minus 3 in its own set of parentheses. Now, you should double check that this won't factor any further. X squared minus 3 won't. If this was x squared minus 4, though, that would be a difference of 2 perfect squares, which is what we talked about in the last video, and you would be able to further break that down. So you should always check to make sure that you have factored things completely. So here's another example. So you can see that we have 4 terms. When you have 4 terms, you should automatically think to try factoring by grouping. Before you even try grouping, however, if you can take a GCF out of all 4 things, you should do that. GCF is always the first step, no matter what factoring technique we use. In this case, there is no GCF, so we are going to proceed to group them together. And you can see, again, there was a negative right here on the 5. The negative gets grouped inside the parentheses, and then a plus sign gets put in between them. So after we do that, we are going to proceed to take the GCF out. Okay, so in the first one, you need to take x squared out. That is the GCF of x cubed plus x squared. When you take x squared out, you'll be left with x plus 1. In the second set of parentheses, you need to take a negative 5 out. And when you do that, you will be left with x plus 1 as well. And remember what I said in the last problem. Once you take the GCFs out of each group individually, what you should be left with should be the same. And in this case, it is. X plus 1 is the same as x plus 1. That has to happen in order to proceed to the next step. So we will regroup x squared minus 5. It says plus negative 5, and that's fine. But it's x squared minus 5. We're going to regroup that, and then we will write one of the x plus 1's. That's exactly what we did. Double check that this x squared minus 5 won't factor. It will not. Sometimes it will, and you'll need to break it down further. But in this case, 5 is not a perfect square, so you can't break it down, and that is the final solution. And please note, too, if you ever want to double check that you did this correctly, especially if you're taking an assessment, you can refoil this together. And when you refoil it together, you should get the original expression. Okay, so that's what I got for you today. As always, if you have any questions, feel free to email me. Have a great day.